Hey folks, welcome back to physics. In this video, you are going to learn about adding and subtracting vectors in 2 dimensions. By the end of this video, you will be able to add and subtract vectors in both 1 dimension and, as you'll learn in this video, 2 dimensions. So let's go ahead and jump right in with an example. Michael walks 3 meters north and 4 meters west. Where does he end up? So what is his final position? Let's go ahead and figure that out. And to start, what I'm going to do is go ahead and draw my vectors on this nice board, on this nice grid. So let's go ahead and draw 3 meters north, and we'll say he starts at this point here. It doesn't really matter which point we pick as long as we have enough space to draw all of our vectors. So he's going to start at this point, walk 3 meters north, and then turn and walk 4 meters west. Now, this is just for everybody's sake. I want to remind you all of your compass directions. So we're going to draw that compass north, south, east, west. And I like to remember, if you start at north and you go clockwise around, you can use the mnemonic never eat soggy waffles to remember your compass direction. So north, east, south, west, going in our clockwise direction. Anyway, let's move forward back to our example. So we have Michael who walked, again, 3 meters north and 4 meters west. And we're going to figure out his final position. And to do that, I'm going to start at my starting position and draw a vector that points directly to my ending position. And as you can see, this is a really nice shape. It is a right triangle. So I can even draw my little right angle sign. And I know this because I have to turn 90 degrees to go from north to west. So that means that this angle that I drew has to be, this one, has to be 90 degrees. So, as with any right triangle, we can use the Pythagorean theorem, which is a squared plus b squared equals c squared, to figure out the length of our hypotenuse, which is this long side, the side that is directly across from my 90-degree angle. So let's go ahead and figure out the length of that vector. So we've got a squared, and I'm going to say a squared is that 3. It doesn't really matter which I pick for a or b. So a squared plus b squared, so plus 4 squared, is equal to c squared, where c is, again, my hypotenuse, and is the distance that I am from my initial position. So let's do the math. 3 squared is 9. 4 squared is 16. 9 plus 16 is equal to 25. So c squared is equal to 25, which means that c, again, our displacement from our initial position, is equal to 5 meters. And so that is how far Michael is from his initial position. Now, I am not quite done. I have to figure out, so remember, a vector has both magnitude and direction. This here is my magnitude, but I still need to find the direction of c. And so I'm going to go ahead and draw my compass again at my starting position. And we're going to go ahead and draw our north, our south, our east, and our west on our compass. And we can see that our final vector, that vector c, is pointing to the northwest. So it's in that northwest quadrant. So Michael ends up 5 meters northwest of where he started. So that here is going to be our final answer. This one is slightly more complicated in that we have 3 vectors now. So Pam walks 8 meters south, 4 meters north, and then 3 meters east. And again, we're going to figure out where she ends up, what her final position is relative to her initial position. And so we're going to start again drawing our vectors. I'm going to go ahead and pick a nice spot over here to start drawing. So she starts by walking 8 meters south, so 2, 4, 6, 8 squares. And then she turns around and walks 4 meters north. So we're going to go north 4. Next, she's going to walk an additional 3 meters east. And so this is her final position. So we're going to draw our vector, starting from our initial position, and again, going straight to that final position, which is going to be the end of the last vector that we drew, that 3 meter east vector. So what's really nice here is that we have done the math for that 8 meters south plus 4 meters north on our picture. So we went 8 squares south and 4 squares north. So we went -8 meters plus 4 meters, meaning that this length here is going to be, we'll say it is -4 meters from where Pam starts. So let's go ahead and add that to our graph. So this distance here is going to be -4 meters. And this side here will be 3 meters. And again, we're just going to add in our directions, and you'll see very quickly that it doesn't really matter whether this is negative or positive. I'm going to go ahead and label my hypotenuse as C, and I'm going to go ahead and put in my right angle, because again, I know that south and east are at 90-degree angles from each other. So as in the previous problem, I can use the Pythagorean theorem to solve for C. So we've got our first side, which is -4 meters, so -4 squared, plus our second side, which is 3 meters, and so we're going to square that 3. And that is equal to C squared. So -4 squared is positive 16, because remember, a negative times a negative is a positive. If you're putting this in your calculator, please make sure that you put parentheses around that -4. Otherwise, your calculator will think that you were saying -1 times 4 squared, which would give you -16, which is not correct. So again, parentheses are very important. So anyway, 16 plus 9 is equal to C squared. So C squared is equal to 25. And if we square root both sides, we get that C is equal to 5 meters. And again, we're not quite done, because we have to have the direction that Pam has walked. So let's go ahead and draw in our compass. And again, we have our 4 sides, and north, south, east, west, never eat soggy waffles. And so you can see that our arrow is in that southeast quadrant. So Pam ends up 5 meters southeast of where she started. So there you go. We have solved a slightly more complicated two-dimensional vector problem. So let's go ahead and talk takeaways. First of all, vectors are always added head to tail. So this is true in 1 dimension, and it's also true in 2. Secondly, when you're adding vectors in 2 dimensions, you'll need to use the Pythagorean theorem to figure out the length of whatever your resultant vector is. So make sure you practice a little bit of your geometry. Okay, so now it is your turn to solve some 2-dimensional vector problems. Give it your best shot. Happy solving.